Welcome once again to my YouTube channel. Today we are going to look into JAMB question on 2025 chemistry from a topic, dilution of concentrated solution. The question reads, what is the volume of water needed to be added to a solution containing 0.52 mole of the solute in 1 dm cube to dilute it to 0.32 mole per dm cube? We have the options A, 1629 cm cube, B, 625 cm cube, C, 505 cm cube, D, 495 cm cube. Now the question from dilution of concentrated solution, hence it has a formula. So to solve the exercise solution, now the formula for dilution formula, we have it as C1 V1 equal to C2 V2. Here C1 means initial concentration of the solution in mole per dm cube. C2 means final concentration, the final concentration of the solution in mole per dm cube. Then V1 means initial volume in cm cube or rather dm cube. Then V2 means final volume of the solution in cm cube or rather dm cube. Now, if you know the parameters C1, C2, V1, V2, then you can get the volume of water needed. Now, the volume of water needed, which I will now represent with V, will now be V2 minus V1. That's the final volume minus initial volume. That gives the volume of water needed. Volume of needed water. So, we have to now get the parameters given in the question. So, from the question, what volume of water needed to be added to a solution containing 0.52 mole of the solute in 1 dm cube? So we have 0.52 mole as the initial mole and 1 dm cube as the initial volume. So we have Na1 equal to 0.52 mole. Then we have V1 equal to 1 dm cube. Then from the question again, to dilute it to 0.32 mole dm cube, we have the final concentration at 0.32, C2 at 0.32 mole per dm cube. Now, we don't have V2 here, hence, to get this V2, we need to get every other parameters from the given parameters. So we have Na1, we have V1. So we can now get initial concentration, which is Na1 over V1, because concentration is the amount of a substance contained in 1 dm cube of a solution. So to simplify this, Na1 over V1, hence we have initial mole, we have it as 0.52 mole all over initial volume, which is 1 dm cube. When you divide 0.52 by 1, we are going to have 0.52. Then mole divided by dm cube, we have mole per dm cube. Now we've got the initial concentration. Now, employing dilution formula, which is C1 V1 equal to C2 V2. Now we are to get the value of V2. So we make V2 the subject by dividing both sides by C2. So we have V2 equal to C1 V1 all over C2. So our V2 now becomes C1, we have it as 0.52 mole per dm cube times V1, which is 1 dm cube, then all divided by C2, and C2 here is 0.32 mole per dm cube. So here, the unit, we cancel the unit, that's mole per dm cube. Then we are now left with 0.52 times 1 dm cube all over 0.32. So 0.52 times 1 dm cube, then we are going to have V2 equal to 0.52 dm cube divided by 0.32. So if we employ the division using our calculator, so we have here 0.52 divided by 0.32. Then we are going to have V2 equals 1.625 dm cube. Now we've got the value of V2. So in order to get the volume of water needed, we now have V, which is equal to V2 minus V1, now becomes V2, we've got that as 1.625 dm cube minus V1. V1 here is 1 dm cube. So if you minus 1 dm cube from 1.625, then we are going to have 0.625 dm cube. Now we've got the answer, but from the options we have it in cm cube. So you remember that dm cube means 1000. That's 1 dm cube is equal to 1000 cm cube. So we are going to replace this by 1000. Hence we have V equal to 0.625 times 1000 cm cube. And if you multiply this, you are going to have 625 cm cube. And that gives the final answer. So if you check in our option, then we have option B as the correct answer. See you in our next class. Subscribe, share, and turn on notification for others to learn.